Blockchain has become one of the demanding technologies. People can avoid cryptocurrencies, one of the applications of the blockchain system, which is used in confidential payment transactions. But one cannot avoid blockchain technology's various applications. It can be used in keeping safe records within health, education, and financial industries, and can be used in supply chain management and agreements, also called smart contracts within corporate deals and regulations. There is no doubt that it has several applications within various industries, but what makes this so special? Yes, it is its structure or architecture. Let's get to know more about blockchain architecture. To understand blockchain architecture, we will have to understand a single block structure. But why a single block structure? Because a single block is a unit of the blockchain, and blockchain is nothing but a chain of blocks or sequence of blocks which holds a complete list of transaction records like a conventional public ledger. Let's talk about the block structure. A single blockchain structure can be understood by dividing it into two parts: block header and two, the block body. Block header. Block header is a portion of a block that contains a set of information or metadata within itself. Simply putting, if we consider the human body as a block, then the block header is the brain. This set of information or metadata includes six primary pieces of information within itself, and these six main attributes or data are: number one, timestamp. Timestamp is a small size data stored in the block header as a unique serial. Its function is to determine the exact moment at which the block has been mined and validated by the network. 2. Block version. The block version's function is to convey which kind of version the block is using. Most of the block versions are blockchain version 1.0, which is the cryptocurrency version. It's mainly used in public ledgers, for example, Bitcoin and Bitcoin Cash. Number 2, blockchain version 2.0, used in smart contracts. Blockchain version 3.0, also called DAPS, it talks about decentralized applications. Blockchain version 4.0, which is the blockchain used in industries. Next, Merkel Root. To understand Merkel Root, we will now have to understand the concept of Merkel tree. Now, what is Merkel tree? Well, to get a hash value of each block, we use this concept. A block within the blockchain system contains a number of transactions, and each transaction is assumed as the leaf of the Merkel tree. And these leaves or transactions have their own hash values. A number of leaves or transactions make sub-branches, and eventually all of the branches hash value refer to the hash value of the Merkel root or the hash value of the whole block. So Merkel root describes the hash value of the entire block. Fourth, difficulty target. The difficulty target refers to the measurement of difficulty level within block mining, where mining is a peer-to-peer process, P2P process, which is used to secure and verify transactions. This blockchain mining process is done by blockchain miners who add data transactions to the distributed public ledger. Number 5, nonce. Nonce is a number that can only be used once. In cryptocurrency, it's a one-time code. In the mining process, the main purpose of miners is to find the hash value below a target number, which is calculated based on the difficulty level. The server generates the nonce or a nonce and sends it to the client. The client uses the received code, adding it to the password before encryption, encrypts the received string, and returns the resulting message to the server. The server decrypts the message from the received string to subtract the known nonce and verifies the password. The nonce is used once and only once. All subsequent transfers of passwords with the same nonce will be rejected by the server, so an attacker who intercepts a message with an encrypted password will not be able to gain access by responding the intercepted message to the server. Sixth, previous hash. The previous hash is the hash value of the previous block lying within the blockchain system. Through a combination of pointer and hash function, blocks connect themselves and do the chain formation. And the same reason is behind the tamper-proof ledger, which is if any person tries to break the chain or edit any information, he will have to change the whole chain of blocks, all of the nodes. Otherwise, it will regain its previous form. Next is the block body. The content of the block body depends on the number of transactions and the size of the blocks. Above, we have studied about the following things: about a single block architecture in which there is a block header, which contains a block version, timestamp, Merkel root, difficulty target, nonce, and previous hash. And in the block body, we have the Merkel tree and the list of all transactions. When we put all of it together and link similar blocks, we get a whole blockchain architecture. At first, the genesis block formation is done by the blockchain developer. Then, new nodes show their interest within the particular blockchain system and the transaction cycle continues.